Now I don't see. Okay, whatever. Do you have the thing for the clicker so I can connect it? Okay, then I'll just stay. Okay, I forgot my clicker at home, so I'll just stand like so. Okay. Why? Yeah, the USB-C. Okay. Okay. Let's hope it'll work. Welcome, everyone. Yeah, let's talk about observability a little bit. So quickly on me, I already got an introduction. Maybe relevant for this crowd, I'm also an organizer of FOSDEM, which is collaborating with COSCUP, just trying to bring more open source to communities around the world. So if you look at today's reality, a lot of time you have a lot of different systems and you have disparate systems, and it's hard to navigate information about the systems which you're running. Things might look different. Something might be green in one system and it might be red in another, or go up is good, and maybe something is on the left or on the right in different systems. It's not very great. So let's rethink how we do monitoring, how we do observability, and really start from the basics up. And let's start with how humanity deals with data. So what you see here is an interface by Yanitza, which is the market leader in power measurement. And what you see is a graph, and also you see key events or a short burst of energy as log lines. And this is already taking a little bit of the learning. Highly optimized systems tend to be numbers first, and then for really important things like due diligence, security, compliance, you have a little bit of logs. But let's build to this story from the basics. What you see here is the Stahlschlüssel. It is a book which has been in publication for over 100 years. Any steel which is being produced on Earth, you find in this book. Everything, no matter where on Earth it is being produced. All the physical properties, chemical composition, everything you can find just in this book, for everything. And it is just numbers. All of the properties of all the different steels which we as humans have had over 100 years is just numbers. This is a logbook from a whaler. Logbook is like, this is where the term logs is coming from, where you threw the log overboard and you counted the knots and you knew where you were on the high seas. And if you lost that book, you starved, very easy. So point is, from the external perspective of that ship, or for that ship, everything which mattered about the ship was in this book. What whales they caught, who got paid when, where did they land, who did they pay, whatever. All of this was in this book. All of the existence of the ship is in this book. That's the first letter we know of. It's a complaint letter about the wrong grade of copper being delivered, but the buyer is still making provisional payment. And this is the first writing we have, which is roughly 5,000 years old. It likely tabulates who owned what slaves at one point. The point here is, humanity has always optimized data in the same way. Something is worth doing. You write down the whole story. It keeps worth being doing, and it becomes too expensive. So you compress into the key events. As this keeps being worthwhile, as it keeps being worth doing all of this, again, it becomes too much data. You compress it into numbers. Numbers are great. You can do statistical analysis on them, you can do math on them, you can do formal proofs on them, as we just saw. Numbers are the most distilled form of information which we as a species have. And this pathway has been walked through again and again and again ever since we have had written records, and probably before. So any established industry is numbers first. If you consume water or power, you get a number by the supplier, that's the consumption. You get another number, this is how much you have to pay per unit. Another number, this is how much you have to pay. Another number, this is where you wire the money. It's all numbers. By extension, my argument is that IT is not super mature yet, because the vast majority of IT tends still to be logs first and events, not numbers, not extract all of the information into pure knowledge. So let's walk through a few buzzwords before looking at solutions. Observability is a buzzword. Actually, who here has heard observability before? Okay, I mean, it's a buzzword, so it kind of stands to reason. Stupid question, okay. usually a kernel of truth to any buzzword. There's something called cargo culting, which is a term which was coined after Second World War, where Pacific Islanders observed strange people coming, and they did, like the strange people did little marches, and they cleared forests and built towers and built fires, and they did all this, and God started sending gifts from heaven and over the seas. Those were soldiers, and they built out small landings on the islands, and then planes and ships dropped cargo. But the islanders didn't understand this. They observed behavior of something doing something, and they observed behavior or they observed results. And everything in between they made up as good as they could. So the point here is not to throw shade on the islanders. The point here is this urge in humans, when they see something work and see success, there's a very deep urge to replicate the success and basically replicate the success to however you know. I mean, literally, this is part of why we are here, to replicate all of the success of open source and make it even bigger and more. So this is really, really built into humans. So monitoring used to basically mean what we call alerting, observability these days, and like buzzwords always are replaced. But the point is, observability means don't just keep doing what you do, you need to actually change what you're doing, because otherwise you're basically like the islanders. You just observe success and you want to replicate it, but you also need to understand why it is successful to be able to replicate the success. So observability, you might have heard a few definitions like functional definitions or tests what it is not. If you can't ask new questions on the fly, it's not observability. Or if you can only determine that something is broken and not why something is broken, it's not observability. Those are more functional and not super precise. There's also this tendency to have more buzzwords, so people call it observability 2.0, 3.0, 4.0. It's just like more buzzwords, but the foundations are the same. And when we go back hundreds of years, observations are approximations to the truth. This can be accomplished in no other way than by suitable combination of more observation than the number absolutely necessary for the determination of unknown quantities. That's Carl Friedrich Gauss 200 years ago, a little bit over 200 years ago. And the modern definition of observability comes from control theory from the 60s, when industrial plants became too large for a single person to understand them. And that's why industry poured a lot of money into people to be able to understand systems. Observability is a measure of how well you can determine the internal structure of a system just by looking at the outputs. And that is everything you need to really know about observability from like a formal definition standpoint, and everything else flows from there. Let's look at a few other things. Complexity. I personally like to discern between fake complexity and real system inherent complexity. If you have fake complexity, please, if you can, get rid of it. You don't need 20 libraries for every small thing. Try to get rid of complexity wherever you can. Real complexity you cannot reduce. You can move it, you can compartmentalize, you should compartmentalize it, and basically make it into easy to handle blocks, but you cannot really get rid of it. Important point, regulated industries like finance and health and such, they do have regulations. These are made up, so to speak, but still they are hard complexities for this business, so don't try to get around them. So what is a service? A service is a unit of complexity with nice interfaces. Can have different owners and everything. Important about services, I like to call the interfaces contracts, because contract is something you sit down, you agree, you discuss, you write down, you put your name to it, and then you keep doing it. And if you want to change what you're doing, or if the other side wants to change what they're doing, you need to talk about it and you need to agree. That's why I like contracts, because it transports a commitment to keep something in a certain state or readiness or availability to other people. The internet would not exist without layers, where it does not matter if this is Wi-Fi or 20 years ago, it would have been a cable. The rest of the internet stack doesn't care about this. So this also means you can just replace different services and different units of complexity, and the whole system keeps running. And even if you cook from scratch, you will not have grown every last cucumber yourself. There's plenty of examples of services around the world. Then this is more for, so who here knows what cloud native is? Okay, less than expected. If you want to talk about it, catch me later. The point of this slide, I'll just go quick then, is basically like the basics of how you think about how computers are structured and where complexity lives changes over time, but fundamentally you cannot move it around. But one thing which has happened recently with all the microservices and cloud services and everything, a lot of previously contained complexity has deliberately been broken up to make it easier to scale horizontally for more users, to allow smaller teams to work on stuff independently on each other. That is basically what cloud native is in a nutshell, at least to me. The point is, a lot of the old tools are not built for this increase of exposed complexity. They have been built for smaller amounts of complexity being exposed to the end user or to the operator. And this is why a lot of the legacy tooling is breaking down when you really scale up your services. So this is why the more modern tooling is able to handle this. SRE, we already heard of SRE earlier. I was kind of, yeah, anyway. Who here knows what SRE is? Okay, so SRE is basically how Google runs production services internally, and it has gotten into more and more services. It has really, I'll link something in a second. Basically, SRE is how Google runs services internally, and you will all agree that Google runs reliable services, I guess. So one of the core things about SRE to me, like they have a lot of things, but one of the core things to me is you have error budgets. From the perspective of the user, it does not matter why something is broken, only that it is broken. So it does not matter if you run a lot of tests and a lot of A/B testing, or if your service is really brittle, or if the software is really bad. It does not matter as long as the user gets good service or bad service. So the point of error budgets is all the different parties who usually fight each other at the company about who gets to do what, they have one shared budget, and this is the errors which the users see. And then they can negotiate this budget with each other, but it takes a user-centric perspective to running software. And this completely changes how you have to think about your engineering and your trade-off. Highly recommended, highly, highly recommended. There are three big things in SRE, SLI, SLO, SLA, and everyone keeps saying them and no one ever explains them. It's very easy. Service level indicator is what you measure. Service level objective is what you have to hit internally, and service level agreement is where you have to start paying third parties or whatever when you are in breach. Also keep in mind as you layer your services that whatever people you rely on use for their alerting and for their observability, you can use for your own as an indicator of something being broken which you rely on. This is a book. It is completely free. I highly recommend you, I'll also have the link at the end of this, but I highly recommend you read this book. It is really good. And again, it is completely free as a PDF on the internet. So yeah, I'll just wait for... Okay. So a lot of what I was hinting at here, and yes, I know I'm speedrunning this topic, is there is, if you do this right, and if everyone, like for example, through error budgets and everything, and through shared shared dashboards and everything, you start to build a shared understanding between different parts of the organization if everyone starts using the same observability tools. It's not the case that you start a meeting and 3 different people have a fight about whose numbers are least wrong. They already agree on the numbers because they already use the same numbers. They use the same systems to observe their own systems. And this has a lot of positive effects where, for example, it creates incentives to improve the tooling which you use internally for everyone. Because one person makes an improvement, everyone else benefits. You also start pooling knowledge, because it is not the case that you have small islands of operations which fight each other all the time. You start coming together and talk together more. And you start building shared language. Who here has heard of the term KPI? Yeah, a few. KPI is key performance indicators. It's used in economics basically for what is important to the business. But the thing is, SLI, SLO, SLA, and KPIs, for example, they mean exactly the same thing. SLI, SLO, SLA, they split it up more, but it is exactly the same thing. So it is often a case of people in different trades and industries do the same things and come to the same conclusions, but they do it independently. They use different words for the same concept, and so they don't understand each other, even if they are literally doing the same thing. So again, by working together and by collaborating and building a shared platform for understanding whatever service you're running, you are short-circuiting this and you actually get together and you talk better with each other. So alerting, super important. Who here has actual alerts for anything they are responsible for? Okay, a few. I was on call for 11 years without break. Very stupid on me. Yeah, I know, very stupid. Anyway, point is you need good alerting because otherwise you will burn out. Because this wakes you up at 4 a.m. on a Sunday, and this happens a few Sundays, and your partner is very unhappy, your family is very unhappy, you get no sleep, it's bad. There is this tendency of once you introduce alerting to alert for everything, and this is really bad. You must only alert on something which is currently or imminently customer impacting, as in right now or very soon. And if it is not, send email, raise a ticket, whatever, do it during business hours. If you still need to wake someone up 5 hours later, okay, you can. But don't wake anyone up, don't stop anyone from family time just because something might be breaking in 6 hours. No one cares. If it's breaking in 2 hours or currently breaking, okay, different. But if it's in half a day, who cares? Maybe it solves itself. Maybe it can wait until Monday. So let's look at a few tools which you can use to achieve all of this. First of all, Prometheus. Who here has heard of Prometheus? Okay. Oh, okay. Good. Inspired by Google's Borgman, like a lot of what I'm talking about has been practiced at Google for over 20 years by now. It's a time series database, so you store numbers, you store metrics. It has thousands of instrumenters and exporters, and it is the default in any cloud-native application for observability. So what are time series? Time series are recorded values over time. If you look at what the temperature is right now and you look at the temperature in an hour and you write this down, this is already a time series. You just track changes over time. Individual events are usually merged into counters. This harkens back to, like, you have key events, you compress them into numbers and make them more efficient. Changing values are usually recorded gauges because they can go up and down. Typical examples of this: requests to a web server, this number just goes up, so it's a counter. Temperatures, they go up and down, so this is a gauge. And histograms is, for example, how much time does it take for your service to answer to whatever request is coming in. Also, for those who don't know, Kubernetes is basically the open source reimplementation of Borg, which is how Google runs their containers internally. And Prometheus is the reimplementation of Borgmon, which is the initial system within Google to run the services with. Quite literally, Google would not exist in its current form without Borg and Borgmon, and that is what you have with Kubernetes and with Prometheus today. They really scale, they're really powerful. Main selling points of Prometheus: it is super highly dynamic. It has built-in service discovery. You don't need to sit down and write down by hand, I have those 5 servers. There's plenty of systems where you just automatically tell Prometheus where to get this data, and it just does it. You can just tell it there's a Kubernetes that gets all of this. You can tell it, like all the cloud providers have interfaces. So you just connect and you know what should be there, and you start scraping it, observing it, and it just happens automatically. If you have a DNS zone, you can just do DNS zone transfer. There's dozens and dozens of ways to get a list of what should be monitored into Prometheus. It doesn't have a hierarchical data model, so you don't have, like, if you say you have region and then you have deployment and then you have customer, and your boss comes and say, I want everything by customer, so now you write a lot of code to transpose your tree and you're very unhappy. Prometheus just has an n-dimensional matrix. So it's just say select by customer and done. It's super convenient. And you have one single language which you use for everything. It doesn't matter if you alert, if you want to visualize it, if you want to create new data, if you want to export, all through one language. It's just incredibly powerful because once you're used to this, you see how many ways other systems have to get data out, and it's super annoying, super inconvenient. Yeah. It's very easy to get data into Prometheus. I know people who literally just print F into a text file and then they put it on a web server. So this is how you would do this kind of thing. You can do math on your observability data because it is already numbers. So why wouldn't you just be doing math on your data? This is the first time in monitoring and observability that you were able to do math on your data, and it is absolutely brilliant. I love it. 10 years on, I still love it. Scale, you can write easily 1 million samples per second on current hardware, roughly 200,000 samples per core on any modern system. Any data point within Prometheus takes up 16 bytes uncompressed, which compresses on average to 1.36 bytes. That becomes relevant in a few. And you can run tens of millions just on this laptop, I can run tens of millions of active series. Mimir, it's a Grafana project for metrics. Our projects always start with the same letter of what they do. So Mimir is for metrics. Basically, it is a horizontally scalable implementation on top of Prometheus. It scales to more than 1 billion active series. Active series being defined as has received data within the last 2 hours. It is super fast in performance. Has a lot of features. It supports other formats like OpenTelemetry, Datadog, Graphite, Influx. In the commercial version, you can also use Graphite and Datadog languages to query it, but not in the open source. But you can write and read with, like you can write other data and you can read with PromQL in open source. Yeah, for 1 billion active series, you roughly pay 1,500 machines, 7,000 CPU cores, 30 terabytes of RAM, which is a lot, but also it's cheaper than most other systems which can handle the scale. Then we come to Loki for logs. Follows the same label-based systems as Prometheus. I don't have the time to fully go into why labels are best, but if you want to catch me later, more than happy to. Problem with a lot of systems is you send too much data. If you full text index, you waste a lot of resources, and with labels, it's a lot more efficient. Again, if you want more details, catch me later. Works with logs at scale without all the massive cost of most of the log systems you have today. And also you can actually turn logs into metrics, which supports you in this journey to become more efficient and more numbers first. This is how it looks. Also very easy to write and create. The largest clusters we have at Grafana, we store 180 terabytes per day. And our peaks regularly go to 900 gigabytes, not gigabit, gigabytes per second and higher. We actually find performance issues at cloud providers with how efficient Loki is and how quickly it reads. Tempo for traces, that basically tells you how a request went through your system. Historically, like a lot of solutions for traces tell you you need a lot of metadata on your system, and this is very, very expensive. And it also means you have very short retention, sometimes as low as 3 days. But traces are this full story, which I mentioned earlier. So it is the most uncompressed version of observability data you can have. You already have your logs, you have your metrics. So Tempo is built in a way where it leverages both the metrics and the logs you have. And if you have an error, you can jump directly into the trace. You don't have to search through all the traces. You know directly where your error is. Very convenient. Again, I don't have the time to go into full detail, but if you want, just catch me later. A few numbers. You probably read them faster than I read them out. So one look at cost savings which you can achieve. So as I mentioned, Loki is already super efficient when it comes to logs. But yet, so if you look at full text indexing for 10 terabytes of logs, you have roughly 20 terabytes of index. 20 years ago, you would have had roughly 21 terabyte of index, so very good improvement over the last 2 decades, yet it still doubles your index. The index for Loki is just 200 megabytes, not 20 terabytes. So yes, you can already see like huge jump in the size of the index, and it is as performance. Sorry, I'm a little bit jet-lagged, I'm mumbling. Anyway, I'm going to make it quicker. So logs at Grafana, roughly on average across all the clusters, we have 600 bytes on average per log line. That's like over a huge data set, that is our average. As I mentioned earlier, metrics are 1.36 bytes on average. That means if you turn a single log line into a counter for a metric, on average, you save 99.8% in storage size for the first log line which you transform. And you save those 99.8% every 2 hours. Every follow-up you basically save 100%. Of course, the counter going up is basically free. Because again, on average 1.36, so this average is already in the numbers. It is insane how much money, how much effort, how much storage, how much compute, how much everything you can save once you start turning your logs into metrics, your traces into logs, into metrics. It is insane how much money you're going to save. So super quick look at Grafana. Oh, by the way, who here knows what Grafana is? Okay, good. This is why I keep this super short, because everyone knows what Grafana is. Grafana is a way to make your data beautiful. It's the super short version, and it supports pretty much everything which has data. So it's very easy to get data into Grafana and to visualize it and to write alerts and get dashboards and everything. We can visualize in many different ways. If you want to play around with this yourself, we have a link to playgrafana.com.org where you can just do whatever. While you take picture of this QR code, I'm going to take one picture of the audience. Efficiency, German efficiency. And all of what I talked about, except for the query bit of Mimir, if you want to use Datadog or Graphite language, but everything else which I talked about is open source, so you can run all of this yourself without ever having to pay anyone. Harken back to two talks earlier, if you want to pay us, you can also talk to me, but like, seriously, you can just take the open source and run it, and you can be successful without ever having to pay for any of this. This is the power of open source, and this is why we believe in open source. Thank you. So left is Mastodon, right is this talk if you want the slides. I need to upload it after this talk, but I will upload it right after this talk. And if you have any questions, feel free to ask.
Okay, I know Grafana and everything is open source, but for, let's say, an enterprise who has been signing contract with a certain cloud provider, they could use the offering from those cloud provider, right? So what's the advantage of using an open source software which the data ends up in the same cloud? So kind of want to figure that out.
You mean how to decide which service provider to choose from?
No, let's say a company has decided, okay, all my metrics, logs, traces are going to one of the cloud provider, and we already signed a contract, so we're not going to change that, right? So should we just use the native offering from that cloud, or we should use, offering from Grafana, which is of course open source? Yeah.
So I mean, in this case. So just to make sure I have the question right, basically the question is, if you're already committed to one cloud provider, how do you choose if you buy from this cloud provider or if you run it yourself?
Should we just use their client libraries to upload our metrics?
Understood. So you can just run open source on their cloud. Every major cloud provider also has has managed offering for Grafana and related components. So you can also choose this, or we also run on all major clouds. Honestly, if you look at the versions and at the time to upgrade, Grafana's own offerings tends to be much quicker. Cloud providers tend to take a long time, a surprisingly long time to deploy software. So my own preference would probably either be to run it myself as open source or to buy from Grafana Labs. I'm obviously biased, just to be clear, but like. The speed of upgrades, level of support, level of bug fixes, from my experience, tends to be best at the direct upstream service, which is us. Which stands to reason because we have all the software engineers writing the thing, so we know better how to make it run. Other questions?
Hello, I'm Sherry. And as you know, that I think most of us are struggle of a lot of metrics, and when something arose, and sometimes it's very hard to identify that is important. Some metrics are important. Even we have clarified each level of metrics, but something will missing. And can you based on your experience, and to summarize which are the top 3 metrics that you think is very important.
The top 3 metrics which are important. Okay, I think I actually have a good answer, but before, like on a very fundamental level, because part of your concern is you have too many metrics and it's kind of useless and expensive, but also you don't have all of the metrics which you actually need. So part of this is you're never really done adding and removing metrics. So it is not, it's like one thing I've often seen is developers think they write a counter once and they're done forever. And this is not the case. As they use the metrics to understand the system, they also need to change and update what they are emitting. Sometimes they need more details, sometimes they can get rid of something, and this is something where also developers need to just get into this mental mode of continuously improving and not just doing it once and pretending they're done forever. Most important metrics, I would say, is anything customer facing. So for example, if you should absolutely count any request which you receive and which you give back. Just counters. Counters are very cheap and very low effort. So, but now if you also count how many are successful, how many are errors, how many are maybe timed out, how many states you have, doesn't matter. You can already do things like, for example, take a ratio of successful requests versus unsuccessful requests. And if this spikes up, you know something is bad. There are things called red method and use method, request error duration. So the request rate, the error rate, and the duration it takes for your whatever it is to finish and to answer. Use is utilization, saturation, and I forgot the E, it doesn't matter, where you focus on the utilization and how saturated your services are. Google calls them the 4 golden signals, which you can also find in the book which I linked. And if I had to choose only very few metrics which I get, I would use the 4 golden signals. It is absolutely the essence of decades of industry experience, that those are the most important ones. They tell you something is wrong or it is correct. Then you need more metrics, obviously, to figure out what is actually happening and what is wrong, but you also usually need some logs, some traces, and then you can actually figure stuff out. But like the most important, 4 golden signals. I'm getting the signal. Okay, no more questions. Thank you.
Thank you, Richard. Let's give a last round of applause to the speakers. Okay.